Welcome to this lesson. We're going to take a look at bonding. So this topic is going to be delivered into two videos. This is the first video and there will be part 2. So in this video we're going to take a look at introduction, then we'll move on to ionic bonds, which are just a type of bonds. Then in the second video we're going to take a look at covalent bonds and metallic bonds. Let's get started. So what is bonding? Bonding is just a chemical combination of two or more atoms. When two or more atoms combine chemically, they are said to form a bond. So here are some facts about bonding. The first is when two or more atoms form a bond, elements, molecules, and compounds are formed. So a compound, a molecule, or an element is as a result of bonding between two or more atoms. Secondly, only outermost shell electrons take part in bonding. So for atoms that have multiple shells with electrons in the shells, only electrons that are in the outermost shell take part in bonding. For this reason, electrons in the outermost shell are called valence electrons. So why do atoms form bonds? Atoms form bonds in order to be stable. An atom that hasn't formed a bond, it's not stable. But let me put it in this way. There are some atoms which are naturally stable, but most atoms are not naturally stable, and they can only be stable when they form a bond. So what does it mean to be stable? An atom is stable if it has maximum number of electrons its outer shell is capable of having. So if you have been given an atom, if you look at its outermost shell, if the outermost shell has a maximum number of electrons that it is capable of having, then that atom is stable. Here are some examples. There's another way in which we can take a look at, or we can understand stability, but this is one way. Let's take a look at examples, then we'll try to define another way. So here is chlorine, and the electronic configuration for chlorine is 287. So the third shell, which is the M shell, has 7 electrons. The maximum number that the M shell can accommodate of electrons is 8 or 18. Okay, it's 18, but when it comes to bonding, the base is 8, because for this to be stable, it only needs 1 electron, then it's stable. So if it was 18, then it needs 11 electrons. So naturally, we look at 8 as the maximum number of electrons that an atom would need for it to be stable. There's another explanation which is coming soon, and it's very straightforward. So this chlorine atom, for it to be stable, to gain 1 electron, and it will have this structure 288, and since it has gained an electron, it will become a chloride ion, and we write it with this symbol, where the -1 suggests that it has 1 more electron than protons. Remember, electrons are negatively charged, so if it has gained 1 electron, then we put a -1. Another way in which to look at this, the one that I used to like, was when I see something like this, I'll be like, this one has something that has 1 particle that has to be subtracted from it. So 1 particle has to be subtracted from it. That's why this -1 used to remind me. So I could say, for this one to get back to its original atom, 1 electron has to be submitted. I mean, has to be subtracted. Sorry, yes. So anyway, it's not real science, but it's just another way in which you can look at it. So chlorine Cl -1, you can see it as this one has 1 electron that has to be subtracted for you to get back to chlorine. But basically what it means is it has 1 more negative charge. Then there's another one, sodium 281. So sodium in the third shell, it needs about 7 electrons for it to be stable. So it can gain 7 electrons, or instead of gaining 7 electrons, since those are difficult to find, it might just lose 1 electron. And if it loses an electron, then the third shell is going to have 0 electrons. If the third shell has 0 electrons, it means the third shell will stop existing, and the outermost shell is going to be the second electron, which has 8 electrons. I mean, the outermost shell is going to be the second shell, which has 8 electrons, and it is stable. So sodium would lose an electron, and it will have this configuration 2, 8. And we are going to indicate the sodium ion as Na plus 1, meaning that there's one more proton than electron, since 1 electron has been lost. Using my non-conventional way of understanding this, if I have this sodium plus 1, I could just see this as it needs 1 electron to be added for it to go back to its original atom. Just to understand what this means, when you see this, what should it tell you about this particle? So this is how I used to understand it. Chlorine minus 1 means 1 electron has to be removed. Sodium plus 1 means 1 electron has to be added for both of them to get back to their normal states. Another interesting case is hydrogen, which has a configuration of 1. So how can hydrogen be stable? So in the first shell, the maximum number of electrons that should be there is 2. So hydrogen can gain or it can lose. If it gains, it will have 2 electrons. If it loses, it will have 0 electrons. And if it has 0 electrons, it's okay, then it's stable. So hydrogen anyway is a special case which we're going to study later. So there's something about metals and non-metals. Metals tend to lose electrons, and non-metals tend to gain electrons. Chlorine is a non-metal, so it has gained an electron. Sodium, it's a metal, so it has lost an electron. So this is a fact that we're going to be using, especially when we look at what is called ionic bonding. So now let's understand stability. So stability can be deduced from the structure of noble gases. So noble gases are gases in the 8th period or period O of, noble gases are gases in the 8th group or group 0 of the periodic table. So noble gases are atoms that have 8 electrons in the outermost shell, except helium, which has only 2 electrons. So all noble gases have 8 electrons in the outermost shell. Helium only has 2 electrons in the outermost shell. And all noble gases are stable. They don't react, or they don't combine, they don't form bonds with other atoms or elements. So noble gases are said to be stable because of this. So because some noble gases have 2 electrons and they're stable, while others have 8 electrons and they're stable, we say that helium, or any atom that becomes stable by having 2 electrons in its outermost shell, usually the first shell, obeys what is called the duplex rule. So the duplex rule states that an atom is stable if it has a maximum number of 2 electrons in its first shell. Then other noble gases obey what is called the octet rule. So the octet rule states that an atom or element is stable if it has a maximum number of 8 electrons in its outermost shell. So most atoms, when they try to be stable, they go for octet rule. But some try to be stable by following the duplex rule. So in short, an atom can be stable if it has the maximum number of 8 electrons in its outermost shell, provided that the outermost shell is not the first shell. If it is the first shell, then 2 electrons will make it stable, because the maximum number of electrons that the first shell can accommodate is 2 electrons. So here's some of the structures of noble gases. The first is helium, which has the electronic configuration 2. Neon has 2, 8. Argon has 2, 8, 8. So you can see in the outermost shell, helium is the only one with 2. The others have 8, 8. And they are more examples of noble gases, but the structures always end up with 8 and they are all stable. So all atoms other than the ones that are part of the noble gases try to be stable by having this configuration or having 8 electrons in the outermost shell or 2 electrons in the outermost shell if the outermost shell is the first shell. So I talked about metals having the tendency of losing electrons and non-metals tending to gain electrons. So how do we tell if something is a metal or a non-metal? So we use the periodic table. So elements in group 1, group 2, up to group 3 somewhere, all these are metals. Then elements from group 8, this group 0 is also group 8, group 7, group 6, group 5, and some of them in group 4 are non-metals. So if you pick something like sulfur, it's a non-metal, chlorine non-metal, oxygen non-metal, nitrogen non-metal. But if you pick from here, anything here, it's a metal. So these things that are in group 1, group 2, group 3 all tend to lose electrons. Well, these in group 4 going upwards tend to gain electrons. So types of bonding or types of bonds. There are 3 types of bonds that we're going to discuss. The first is ionic bond. The second is covalent bond. The third is metallic bond. So we're going to start with ionic bond. So ionic bond is also known as electrovalent bonding. Ionic bonding involves the transfer of electrons from a metal to a non-metal. So ionic bonding, basically it involves a metal which always loses, it will lose an electron, and a non-metal which always will gain an electron. So one will act as a donor, donating an electron, and another one is going to act as a recipient, receiving an electron. So one of the key words that we're going to be using, or that you might be coming across as you venture in your studies, is electrovalency. So electrovalency is the number of electrons lost or gained by an atom. So if an atom loses 5 electrons, then its electrovalence is 5. If an atom gains 3 electrons, then its electrovalence is 3. So just to emphasize the point, metals lose electrons and non-metals gain electrons. So ionic compounds. What are ionic compounds? Ionic compounds are compounds formed by ionic bonding and consist of cations and ions. So an ionic compound is made of a positively charged ion called cation and a negatively charged ion called anion. Remember, when an atom loses an electron, it will have a charge of positive 1 if it has lost 1 electron, and since it is positively charged, it's going to be called a cation. Then another one which is going to receive that electron is going to have a charge of a negative, and it's going to be called an anion. So ionic compounds, of course, are compounds that are formed when an ionic bond has been formed, and for an ionic bond to be formed, one atom has to lose, the other one has to gain. So one will be positively charged and the other one will be negatively charged, and they'll be attracted like that. So here are some examples of ionic compounds. The first one is sodium chloride, which is common salt, the salt that we put in our food is sodium chloride. The second is magnesium oxide, and the last one is calcium chloride. So we're going to study how ionic compounds are formed. So here is the formation of ionic compound. We'll start with we're going to take a look at 3 examples. So we'll start with the first one, which is sodium chloride, how the common salt that we eat is formed. So sodium chloride has a chemical formula, NaCl. Na is sodium, Cl is chlorine. So basically you can tell that it is made up of 2 things, sodium and chlorine. So the salt that you eat, part of it is chlorine. So here is how sodium chloride is formed. So sodium has electronic configuration 281 and chlorine has electronic configuration 287. So sodium, which is a metal, it is in group 1, it's going to lose this outermost electron for it to be stable. So sodium, we write like this. Sodium is going to lose 1 electron and it will become sodium plus 1. So sodium plus 1 means it has lost 1 electron. Once it has lost 1 electron, its new electronic configuration will be 2,8 and it is very stable. And chlorine, on the other hand, is going to take advantage of the electron that sodium is going to lose. So chlorine is going to gain this electron here. Chlorine plus electron, E is for electron. This will result in chlorine having a charge of -1, meaning that it has gained 1 extra electron. Its new electronic configuration is going to be 288. Therefore, sodium chloride is going to be formed. In short, this is the balanced word equation, or chemical equation, actually not word equation. This is the balanced chemical equation representing what happens. So sodium plus 1 plus chlorine minus 1, the ions are going to combine to form sodium chloride. So let's take a look at a visual representation of what happens. So this is an atom of sodium and this is an atom of chlorine. So what happens here? So what happens is this electron in the outermost shell is going to be lost and chlorine is going to gain this electron. So once chlorine has gained this electron, sodium will have 8 electrons in its outermost shell. This which once was the outermost shell is having 0 electrons, so it will stop existing. So our new outermost shell is going to be this one with 8 electrons, and chlorine is going to have 8 electrons in its outermost shell. Therefore, the two are stable, and because they have shared something, they are going to form a bond. And this one now, since it has lost, it's going to be it's going to have the formula, or the chemical formula, sodium plus, and this one chloride minus. So the two are going to form a bond like this. This is how you show a bond. In an exam, you can be asked to show how the bond is formed, and this is how to illustrate. So you draw the electronic configuration for the two atoms, then you cover them in these square brackets. When you do this, here you write the charges. So you write positive, it has lost 1 electron, negative, it has gained 1 electron. So this is sodium chloride. Let's take a look at another one, magnesium oxide. So magnesium oxide has the electronic configuration 2H2, and it forms a compound with oxygen, which has electronic configuration 2,6. So magnesium 2H2, it has 2 electrons in its outermost shell, so it's not stable. It can only be stable if it has 2 electrons in its first shell, and the first shell should be the last shell, but these 2 electrons are in the third shell, which is capable of having 8 or 18 electrons. And according to our study, or our definition of stability, we understood that 8 and 2 are the numbers that determine stability. So for magnesium, it needs 6 electrons, and since it's a metal, it has to lose. Metals tend to lose, so it will lose these 2 electrons so that it has 8 in the outermost shell. So magnesium is going to lose 2 electrons and it will become magnesium plus 2, and its new electronic configuration is going to be 2 to 8, and its symbol, it needs a charge here. I forgot to write that. Then oxygen will take advantage of 2 electrons that have been lost, and since oxygen has the configuration 2 to 6, it needs only 2 electrons to be stable, and it's a non-metal, so it gains electrons. So it will gain the 2 electrons, oxygen plus the 2 electrons from magnesium, and it will become O -2. And its new electronic configuration will now be 2 to 8 instead of 2 to 6, so it has gained 2 more electrons. So this is the new electronic configuration for magnesium, and you can write the balanced word equation as magnesium +2 plus oxygen -2, and it will be magnesium oxide. So where has the 2 gone? So the balanced word equation, this is one atom and this is one atom, this is one atom and this is one atom. So this is a balanced chemical equation because the number of magnesium here and the number of magnesium here are the same as the number of oxygen here and the number of oxygen atoms here. So visual representation, So magnesium with its 2 electrons is going to donate the first electron and the second electron to oxygen, and it's going to be magnesium plus 2, and oxygen is going to be oxygen minus. So this is going to result into this compound here with the charge of +2 and -2. So this is our magnesium oxide. Finally, let's study calcium chloride. So calcium chloride is made of calcium and chlorine. So calcium has the electronic configuration 2882, while chlorine has the electronic configuration 287. So how do they form the bond? So calcium, for it to be stable, it has to lose these 2 electrons since it's a metal, so that it remains with 8 as in its outermost shell. So calcium 2882, calcium is going to lose these 2 electrons, and calcium will become calcium plus 2, and the new electronic configuration for calcium plus 2 is going to be 288. Chlorine needs only 1 electron to be stable, but remember, calcium gave away 2 electrons. So how is chlorine going to form a bond with calcium when it only needs 1 electron? This is only possible if there are 2 chlorine atoms available. So if we have 2 chlorine atoms available, then the bond can be formed, because each of the chlorine atom is going to get 1 electron. So here is what happens. Chlorine with its electronic configuration 287 is going to participate in this reaction. So there will be 2 chlorine atoms that are going to get the 2 electrons, each getting 1, and we're going to have 2 chloride ions, each which has gained 1. So the electronic configuration for each of the chlorine atoms is going to be 288, and both of them are stable. Therefore, the chemical or the base chemical equation for this is calcium with a charge of +2 combined with 2 chlorine atoms, and what results is calcium chloride with a 2 here. The 2 shows that there are 2 atoms of chlorine. So there's 1 atom of calcium and 2 atoms of chlorine. So this is calcium chloride. Let's take a look at the visual representation of this. So we have 3 atoms here: chlorine, calcium, chlorine. So calcium has, chlorine has 7, it only needs 1. Calcium, the metal that's going to lose, or the donor, it has 2 electrons, and it has to lose both of them for it to be stable. Then another chlorine also has 7, it only needs 1. So calcium is going to give this to this, and this other one to this. So now chlorine is going to be stable, and calcium is going to be stable, and the other chlorine is going to be stable. Why? Because they all have 8 electrons in their outermost shell. And our the compound that's going to be formed, of course, they are all going to have these configurations, and these are going to be their charges. So at the end of the day, we're going to have this. So we put the square brackets in all of them, then we put the charges on top: +2 for calcium, -1 for one of the chloride atoms, chloride ions, and -1 on the other. So this is calcium chloride. We end this video with discussing some characteristics of ionic compounds. So when I gave examples of ionic compounds, one of them was sodium chloride, which is common salt. So when you're thinking of these characteristics, think of common salt. First, they are made up of positively and negatively charged ions. This is not a fact that I have to discuss in details, as we all know that for an ionic compound to be formed, there will be 2 ions, one being positively charged, another one being negatively charged. 2, they have high melting and boiling points because of strong electrostatic forces of attraction between ions. So when this bond is formed, there are strong electrostatic forces of attraction between the 2 ions. So when trying to remember this fact, just think of salt. Can you easily melt salt? Can you easily boil salt? You need a very high temperature. If salt is not dissolved, or if salt is not dissolved and you try to boil it, it needs high temperature. And also for melting, it needs high temperature for it to be melted. So these have high melting and boiling points because of strong electrostatic forces of attraction between ions. Third, they are soluble in water. but insoluble in organic solvents such as ethanol and petrol. So salt is easily soluble in water. When you put salt in water, it will dissolve, but it's insoluble in petrol. That's one of the characteristics of ionic compounds. Fourth, in aqueous solution or molten state, they conduct electricity because the ions are free to move. So aqueous solution means a solution that is made of water and a solute. So if you dissolve salt in water, what you're going to have is an aqueous solution of salt or of sodium chloride. A molten state means a state in which a solid particle is in after being melted. So it's a liquid state of something that is at room temperature is solid. So if you get a metal, you melt it, then you're going to have a molten state. So even ionic compounds, when you melt them and they have a molten state, then they'll conduct electricity. If you put salt in water, then that water is going to be able to conduct electricity. Why? Because the ions, that's the cations and the anions, move freely in aqueous solutions and molten states. Finally, they are non-volatile and generally solids at room temperature. They are non-volatile and generally solids at room temperature. So what does non-volatile means? It means they don't easily evaporate. So when you put salt just let's say in a pan, it won't evaporate if you don't do anything to it. So they don't just evaporate like paraffin. And generally they are solids at room temperature. Salt is a solid at room temperature. So these are the characteristics of ionic compounds, and this marks the end of our lesson. I hope you have enjoyed and hope you have learned a thing or two. See you in the next lesson. Happy solving.